So we're on week 8, which is Equations and Inequalities. Okay, so we're going to take our basic algebra a step further today. We're going to start using that algebra to solve things. And I'm going to show you a way of solving things that you like, that you can use in the future. Okay. So the learning outcomes for today and tomorrow is we have 3 learning outcomes. I need to show you how to set up and solve simple linear equations. Now there's about 3 or 4 different ways of doing this. Today we're going to do 2 of the 4 ways. We also need to do systematic trial and improvement. Now in Unit 2 it's a bit noddy because all of the answers are nice round numbers. They can't be difficult because you haven't got a calculator. So we're going to revisit this in May when we have calculators and we know a bit more about maths, and we're going to do trial and improvement for quite hard equations. But today I'm just going to show you how it works with a basic equation. Okay? And then finally tomorrow we'll look at something called linear inequalities. All that is instead of having an equation where you have an equal sign, you have a different symbol, either a greater than or a less than. And we'll talk about them tomorrow. Yeah. Today is all about linear equations. And if you tell me or remind me, we've done linear equations 2 weeks on the trot now. What's a linear equation? You will. X has a power of 1. We've mentioned it a couple of times. Because we said when you have x squared, you end up with parabolas. If you have x cubed, you get wavy lines. So here, x has a power of 1, which means it's just on its own. You don't show that one. So an equation of a straight line will be 2x plus 3 equals y or something. So when you've got a power of 1 on your variable, on your letter, it's what we call a linear equation. And I'm going to show you how to solve equations like this today. Okay. Good. So there are 3 ways to solve this type of equation. The first type is usually a 1 marker, and it does what it says on the tin. And that is the common sense approach. So if I said to you, I don't know, r plus 2 equals 6, no brainer, what does r equal? 4. Don't need a calculator, it's common sense, isn't it? That's what we mean by the common sense approach. Trial and improvement. I'm going to show you a trial and improvement method for Unit 2. So I'll show you a trial and improvement method that they possibly could give you in Unit 2. I don't know because they've never given one. Okay? And then finally, there's the correct method for solving problems in algebra, and it's called the inverse method. And what this involves is you get the variable, the letter on its own, by doing the opposite of whatever's being done to it. So if it's got 5 being added, you take it away. If you've got 5 being multiplied by a, you divide it by 5. But you've got to remember what you do to one side of the equation, you do to the other. Good. Now, the inverse method is what we're going to concentrate on today. Tomorrow, we're going to look at something called an inverse flowchart and a function machine, which you may have come across at school, and I have to teach it to you because they can give you questions specifically on inverse flowcharts and function machines. Okay, so we're going to cover all the methods today, or today and tomorrow. Okay, no brainer, common sense method. I'm not going to waste any class time doing this. Yeah, you can just do it in your head. You can see that if I make A2, I get the answer to my question. Trial and improvement. Now this is really difficult for me to show you because they've never actually given a question on it for Unit 2, even though it's in Unit 2 and Unit 3. It's been in Unit 3 an awful lot. Every other paper has it. Okay? So it's a way of guessing. Now you can use common sense and you can also use the systems I've shown you. So the reason this doesn't appear in Unit 2 is because you've got other methods you can solve this in rather than using trial and improvement that are far better. How does trial and improvement work? Well, you put in a number here to have a guess at what the answer is. So if I say to you, I'm going to stick in the number 1, 3x means 3 times 1, 3, plus 4 gives me 7. 7 is too small. So I just pick another number. So I go up to 4. I think, let's try 4. 3 times 4 is 12, plus 4 is 16. Well, that's too big. But I do know I've trapped my answer somewhere between 1 and 4. You can go on what's in the middle. Let's try 2. 2 times 3 is 6, plus 4 is 10. Too small. So I then try 3. 3 times 3 is 9, plus 4, 13. That's trial and improvement, really basic. The reason they don't give you these questions in Unit 2 is because you can solve that in a better way. By the end of today, you can solve that just by looking at it. Okay. So what we need to concentrate on today is the proper method, the inverse method, for solving equations. And in order to understand this, you need to understand the format, how you lay things out. Now, to show you one-step equations, what you do to one side, you do to the other, and you do the opposite to get the letter on its own. So let's look at adding, subtracting, multiplying and dividing, but with really simple questions that you could maybe use off the top of your head, okay? So I've got a plus 4 equals 12. Common sense says it's 8, I don't have to do anything. But I'm going to show you the method, because when we do two-step equations and three-step equations, this method still applies. And if you can do this method, you'll never get an equation wrong again, okay? So I've got a plus 4, and it's equal to 12, so it's balanced. That's what equals means, okay? So to get a on its own, at the moment I've got 4 being added, so I take 4 away. However, I've just upset the balance of my scales. So if I take 4 away from this side, I need to take 4 away from that side. Okay? So these two have cancelled each other out, and it leaves me with a on the left-hand side. On the right-hand side, I've got 12 minus 4, which is 8. So yes, I could use my common sense method, but I'm just trying to show you how the inverse method works for each of our functions. So here, a minus 4 equals 12. So to solve an equation, you're trying to get this on its own. So I do the opposite. I add 4. If I add 4 that side, add 4 that side. So a is now on its own because they've cancelled out. Is equal to... Happy? Yeah. Let's do it for a multiplication. 4a equals 12. Going back to our basics means 4 times a. So if I've got 4a equals 12, what's the opposite of multiplying a by 4? Divide it by 4. If I divide this side by 4, we divide that side by 4. So a is now all on its own on the left, and on the right. Happy? Okay. Final one, division. A over 4 equals 12. So when you do maths proper, what does a over 4 mean? Good. A divided by 4. We don't use this in maths, we use this format. So a over 4 equals 12. So if a is being divided by 4, by 4. So a equals... Can you see how that works? Yeah? In maths, when you get a problem like this, if you got it in the exam, you can just say, oh yeah, the answer's 8, because it will be a 1 marker. If you want to show the examiner how you get that, what do I have to do? Take 5 from both sides, so I'm left with p over here equals 8. So if you get a 2-mark question for something like this, show him the working out. He wants to see what process you're using to work it out. Okay? 6r equals 24. Divide both sides by 6. Can everyone see that? Because it's 6 times r, the opposite is divide. R on its own is 4. You can check your answer. 6 times 4 is 24. And when we do harder ones, I recommend you put your answer back into it to check your answer is correct. Okay, so there are 6 one-step equations there. I don't mind whether you use common sense. I'd rather you use the process I've just shown you, because in a second we're going to do 2-step equations that use the same logic. Okay, so have a go at those 6. So I've got a plus 7 equals 13. So my process method is take 7 from both sides, because it then leaves a on this side and 6 on that side, and when I add 6 to 7 I get 13. Woo! Okay, I've got b minus 3 equals 6. So I need to add 3 on both sides. So I leave b on that side and 9 on that side. 9 minus 3, 6. This one, 3c minus 21. So 3c means 3 times c. So what's the opposite of multiplying something by 3? Divide by 3. If I divide one side by 3, I need to divide the other side by 3. So c is equal to 7. Shout if you're not getting these or I'm losing the plot. The next one then, slightly more difficult. D is being divided by 2. So the opposite of dividing something by 2 is to multiply it by 2. If we multiply both sides by 2, D is on its own now because it's cancelled the divide by 2, and 3 times 2 is 6. E minus 2 equals minus 4. So I'm throwing in negative numbers and all sorts of nasties now. So what am I going to do to get E on its own? Plus 2 on both sides. So that leaves E on the left. Everyone get minus 2. Yeah? So I'm starting at -4 and I'm going 2 in the positive direction. Yeah? We get in there with these. Right, let's do the next one. So I've got -4f equals 32. What does -4f mean in mathematics? -4 times f. So what's the opposite of multiplying something by -4?
That'll be 8.
Divide it by -4. And they cancel each other out. Because we want f on its own. Okay, to get f on its own, at the moment it's being multiplied by -4, you have to divide it by -4. Divide that side by -4, you have to divide this side by -4. So these two -4s cancel each other out to leave f. 32 divided by -4.
-8.
Because I've got a positive and a negative, it's a negative. Right, let's ramp it up a little bit then. Okay? Let's start with two-step equations. These are the bread and butter of Unit 2 and Unit 3. They appear everywhere. We're going to do sequences in a couple of weeks. They will look like this, and I'll get you to solve things that look like this. You're going to be 2p plus 5 equals 13. Now, the golden rule here is you've got two terms. Remember, terms are separated by a plus or a minus. You're trying to get p on its own. So the first thing to do is get rid of the other term. So don't deal with the 2, deal with the 5. So how do I get rid of plus 5? -5. And if I -5 from this side, -5 from that side. So what am I left with on the left? 2p. And what have I got on the right? Okay, so I've got 2p equals 8. As Andre says, to get p on its own, we divide both sides by 2. So we end up with p equals 4. See how I've laid it out? I've told the examiner what I'm getting rid of. I rewrite it in neat for him. I show him what I'm getting rid of, and I rewrite it neat again.
Just like simplifying.
Just like simplifying. Okay? But you're kind of cancelling things out as you go. Let's look at a more complicated two-step equation then. So, good. So my rule is I get rid of the other term first. Whatever's being added or subtracted from my variable, I get rid of. So as James quite rightly says, I have to add 2 to cancel out the -2. So if I do it that side, I have to do it the other side. We write it out neat for the examiner, and we say r over 2, which we've got left, is equal to 6. So I've got r over 2, which means r divided by 2. So how do we cancel it out? Multiply it by 2. If we multiply that side by 2, we multiply that side by 2. So what am I left with on the left? 12 divided by 2 is 6, minus 2, lo and behold, gives me my 4. So I can check my answer as well. So don't forget to check your answer. Everybody happy with two-step equations? Yeah. Like to give some a go? Yeah. Well, I won't torture you with videos. Okay, so 3a plus 7 equals 13, 3c minus 3 equals 21, 7b minus... So the green one's the easy one. This will appear at question 1 or 2 in an exam. The amber ones are your standard ones that would appear at questions 7, 8 or 9. The red one, because it's got the negative number, could appear later on. Okay? Yeah. First one then, green. Who'd like to go on the green? Ladies, talk me through a greenie. Good, -7. Good. So the first step is to take away 7 from both sides. So that leaves me with 3a on that side. Good. Okay. Got 3a equals 6. So what's my next step? Good, because it's the opposite of multiplying it by 3. So a is equal to 2. And we can check that. 3 times 2 is 6, plus 7 gives me 13. 7b minus 8 equals 6. Lewis, talk me through that one.
Yeah, add 8.
Good. So we're getting rid of the other term first. And what am I left with when I've added 8?
14.
I'm left with 14 on the right. And what's on the left?
7b.
Good. Good, good. Okay. And then I want b on its own. I don't want 7b's. I just want 1b.
Divide it by 7.
Good. Divide that by 7. If you divide that side by 7, you divide the other side by 7. So b's now left on its own, and that's equal to 2. Perfect. Getting these? Right, gents, 3c minus 3 equals 21. Ali or Tyrese? Talk me through it. Plus 3.
Plus 3. Yeah.
Plus 3.
Then you should have 3c equals 24.
Good.
And you divide 3c by 3, which should equal 8.
Okay. So c equals 8 when you follow the process. Anybody give the red one?
Plus 7.
Good. Plus 7 on both sides.
And then
What does that leave me with? Tidy it up for me.
D divided by 2.
Good. And it's equal to?
10.
Excellent.
And then times more by 2.
Times them by 2 because we're dividing at the moment. So d on its own now is equal to?
20.
Perfect. And that was a hard one. Hey, sorted. Okay. Just to show you how they come across in an exam. This is from Unit 2 exam paper. The first 2 are 1 markers, and quite straightforward. And I'd also like you to try the part C, which is 2 marks. So remember there are 2 marks, so they want to see you working out. So fine. If you use common sense and put 4, it's only 1 mark, end of. If you're not quite sure how to do it, you can divide it by 3, divide by 3. A on its own is 12 divided by 3, which is 4. Don't get anything for the working out, but it will keep you straight. Like the next one. A lot of people this morning got this wrong because they weren't using the process and they were confusing themselves. How did you get that?
I just times everything by 5.
Good. So the process, which is what I'm more interested in, x is being divided by 5, so I multiply it by 5. Multiply the other side by 5, x on its own on the left, minus 6 times 5 is minus 30. So they're testing you on the sign rule. Let's look at the last one then. 5c plus 4 equals 19. Absolutely spot it a mile away, 2-step equation.
It's minus 4. Are you right?
Minus 4.
Minus 4 on both sides gives me 5c equals 15. Good.
Divided by 5.
Brittany just said divide both sides by 5, so we're showing you how to do this and how to get every mark. So gives me c equals 3. You happy with that? Right. We're going to move on to 3-step equations. So this is the hardest type of equation they're going to ask you to solve in the exam. You can spot them a mile away. Why? How can you spot that this is a 3-step equation? There's an equal sign, and what else is on both sides of the equal sign this time?
Letters.
Good. So the variable on a 3-step equation is on both sides of the equation. So we've done 1 step, we've done 2-step. I'm going to show you how to do a 3-step equation now. And you can spot a 3-step equation because the variable is on both sides. So I'm going to make it easy for you. I'm going to give you the golden rules for solving this. And the golden rules are, first of all, first thing you do is you put the letters together, the variables. Okay? And what you do is you move the small variable across to the big one, so you don't mess around with negative numbers. Okay? So on here, 4a plus 2 equals a plus 11. So Pete's rule says move the a. How do I move an a from one side to the other?
Minus.
Good. An a has got an invisible plus inside of it because it's positive. So the opposite of plus a is minus a. If I minus a from one side, put it underneath so the examiner can see what you're doing. So I've got 4 a's. I take away an a. What does it leave me with? I've still got the plus 2, so I've done nothing to it. On the other side of the equal sign, these two have cancelled each other out. So what am I left with on there?
11.
Do you recognise what's left?
No.
So the reason we deal with the variables first is so that the next thing we see is a 2-step equation, which we're now brilliant at, aren't we? Step 1.
Minus 2.
Step 2.
3 divided by 3. And 3.
So 4 times 3 is 12, plus 2 is 14. 3 plus 11, so my answer works. Okay? So can you see what we did? You move the variable first, and then what that allows you to do is see a 2-step equation that you then just go on to solve. Okay? I'll leave it there for a second for those of you taking notes. Let's do another example together. Okay? So I've got 4h minus 9 equals 3 minus 2h. So Pete's golden rule: get the letters together, but you move the smaller one to the bigger one.
So that'll be plus H.
Well, how many H's have I got over there?
Oh, 2. So it'll be negative.
Right. What have I got on the right hand side? So my smaller one is my 2H. And on the left hand side I've got 4H's. So I'm going to move this one.
So take
What have I got over here?
Minus.
So don't forget the sign that's in front. So what's the opposite of minus 2H? Brilliant. If I do that on one side and put it underneath the 4H so the examiner can see what you're doing. What's the result? 4H plus 2H? And you're left with 6H minus 9 equals 3. Look familiar? Yeah? Starting to get sick of two-step equations? So 6H minus 9 equals 3. Plus 9 on both sides. 6H equals 12.
H equals 2.
Good. 6H. I'm not even getting a chance to do it anymore. You're doing it before me. So I've got three-step equations. Okay? So have a go at those. So I've got 5e plus 5 equals 3e plus 7, which is our green standard one. I've got 5f minus 3 equals 2f plus 18, which is our slightly harder one. And then the last one, don't be frightened of putting the variable on the other side. You don't have to put the variable on the left. The variable can go on the right. Right, let's go through them then. First one, processes.
minus
Going to minus 3e from this side. So we're taking our smaller amount and we're going to move it across. To move it across, we put it over here. So what you do to one side, you do to the other. So 5e minus 3e is
Plus 5.
and that's equal to, happy? Looks familiar? Two-step equation. Take 5, 2e equals 2, so e is equal to 1. Everyone get that? Next one, 5f minus 3 equals 2f plus 18. Step 1, minus 2f from both sides, so that leaves me with 3f minus 3 equals 18. Two-step equation, going to add 3 on both sides, so 3f becomes equal to 21.
F equals 7.
Divide both sides by 3, f equals 7. Everyone get that one? Get in there with these? Got to the 21 bit. Don't forget it's 3f. Last one then, the hardest. 2g minus 5 equals 6g plus 3. Not add.
Oh, you take away.
You take away 2g from both sides and it cancels this one out. It leaves me with minus 5 equals 4g plus 3. So this is a two-step equation. You just don't recognise it because it's the other way around. It doesn't matter that it's been flipped. Treat it exactly the same way. So the next thing,
Minus 3.
minus 3 on both sides. So minus 5 minus 3 minus 8 is equal to 4g. Divide both sides by 4 and g is equal to minus 2. Happy days? Kind of done what I needed to do with respect to the 1 and 2 and 3 step equations. What I'm going to finish off today with is 2 more bits. The first bit is these things called magic squares. Magic squares are solved by using algebra. I gave you one on an earlier assignment that was quite straightforward, that just involved addition and subtraction. You can get them like this, where you can use algebra to solve them. So if I've got a plus a plus a equals 9, in mathematics, what am I saying? So using a one-step equation to solve it, if I divide both sides by 3, a is equal to 3. So I know, common sense or otherwise, that a is 3. Where everybody goes wrong with these is this middle column. I now know that a is 3. So in mathematics, what's it saying to me? What does that say? 3 plus 2b equals, look familiar? Two-step equation. Take the 3 away from both sides. 2b equals 8. divide by 2,
1.5.
b equals 4. 4 plus 4 is 8, plus 3 is 11. Okay? And then finally, you know this is 3 and this is 4, so that's 7 plus c equals 13. Take 7 away from both sides, c equals 6. The reason I'm showing you these is because these are quite easy marks if you use a bit of common sense, but a lot of people waste a lot of time doing them by writing lots of things out. If you can use algebra to solve them, it will speed up how fast you do them. Okay? Final thing of today. I've got an equation in brackets and I need to solve it. What do you think we're going to do first? Brilliant. Open the brackets, yeah. Open the brackets. So let's open the brackets. 3 times a is 3a.
3 times 4.
Plus 12. Does it look familiar?
And two-step.
Brilliant. So the reason we open the brackets is because as soon as we open the brackets, we're staring straight at a two-step equation again. You happy to do that two-step equation with me, Lewis? Yeah? What's the first step to solve this? Brilliant. Take away the 12 by doing it on both sides. What does it leave me with? 3a on that side and 12 on that side. Everyone see that? Next step. Divide both sides by 3. A is equal to 4. 4 plus 4 is 8. Times 3 is 24. We can check our answer. Okay? Have a go on those two. Expand the brackets, solve the equations. Let's go through them slow time. First one. Any takers?
I'll go.
Go on in, Tyrus.
4x plus 28 equals 40. Take away 28.
Whoa, slow down, slow down. So we get 4x, 4 times x is 4x, 4 times 7 is 28. So the equation you need to solve is 4x plus 28 equals 40.
Then you take 28 off both sides.
28 off both sides.
Give you 4x equals 12. And divide both by 4 equals x equals 3.
The amber one. Anybody like a shot at the amber one other than Tyrese? Go on in, Andrew.
5 times 2 equals 5. 2a. So
Yeah.
10a
Good.
minus 15 is
5 times 3 is 15 equals. Good. So we've opened our bracket. So 10a minus 15 equals 35. Good.
Then I've done no.
Don't forget it's a two-step equation now. So what's step 1 of a two-step equation?
Plus 15 on both sides.
Good. Plus 15 on both sides.
And then she'll leave you with 10a equals 50. You divide that by 10 equals x.
Everyone
A
happy?
equals- yeah.
Two-step equations. We've been doing them all day.
That's equal.
So 10a minus 15 equals 35. The first step is get rid of the 15. So you have to add 15 to cancel out the minus 15. You do that to one side, you do it to the other. So that leaves 10a on the left and 50 on the right. You then divide both sides by 10 and a is equal to 5.
NBC.
Happy? I'm going to teach you other ways of solving equations. But inverse flowcharts and function machines are only good for two-step equations. And personally, I'd rather see you do it the way I showed you rather than these. The reason I have to show you these is sometimes they'll give you a question on these. They'll actually give you a flowchart or they'll give you a function machine. So you still need to know how to apply these methods. Okay? So, inverse flowchart. Anyone seen it before? Anyone use this method? What you have is an equation that you need to solve. And what you have to say is, what is being done to A? And it's kind of like bid maths. The first thing being done to A is it's being multiplied by 5. And the second thing that's being done to A is then having 2 taken away. And then what it gives me at the other end is 13. So what you do for this is you quite literally start with your variable and build what's happening to it. So I've got A and it's being multiplied by 5. That gives me my 5A. The next thing that happens to A is it has 2 taken away. So you're subtracting 2 and it gives you your 5A minus 2, which is equal to 13. All you need to do is come back the other way with your answer, 13, and do the opposite. So, if I come back the other way with 13, instead of taking away 2, I add 2, gives me 15. Instead of multiplying by 5, I divide by 5, I end up with 3. So A is equal to 3. 5 times 3 is 15, minus 2 gives me my 13. So the inverse flowchart kind of uses the same inverse method, but you start with the variable and you build what happens to the variable to get to your answer. You put your answer in and then you do the opposite when you come back the other way. And this is only good for 1 and 2 step equations, not 3 step equations. Okay? So, I'll give you another example of one, just to show how you build it from nothing. Just in case you want to use this method to solve equations like this, 2 step equations. Okay? So we're starting off with a variable called P. And you've got flow charts, so you show some kind of flow in a direction. So what's the first thing BidMaths is telling me that I'm doing with P?
Times 4.
Times by 4, yeah? So the first thing I've done to P is multiplied it by 4, and that gives me 4P. And what's the next thing I do to it? I add 3, and the outcome of that is the number 15, yeah? So when I have P and I multiply it by 4 and I add 3, I get 15. So all we do coming in the opposite direction is say, my answer's 15, I do the opposite coming the other way. So the first thing I do is take away 3, which gives me 12. And the second thing I do is do the opposite here, divide by 4, and it gives me 3. So P is equal to 3. 4 times 3 is 12, plus 3 is 15. So can you see how that works? Yeah. Happy? I want to give it a go then. So there's a harder one for you, just to test to see if you know how it works. So V divided by 2 plus 5 equals 21. Just to show that the process works no matter what you're doing to your variable. Okay, so let's go through it. Anybody like to talk me through it then?
V divided by 2 first.
Good. So we've got V at the start and we go this way, and the first thing we do to V, according to BidMaths, is divide it by 2.
Then add 5.
And then that gives us V over 2, and then we add 5 and it gives us the answer of 21. Yeah? So coming back the other way, I stick 21 in, do the opposite, take away 5 which gives me 16, do the opposite, times 2 gives me 32. 32 divided by 2 is 16, plus 5, 21. Okay? Happy with that? Brilliant. One more and then we'll move on. So pretty standard one, 5r minus 2 equals 13. Use the reverse flowchart method and just solve that. Where do I start? R. Yeah, that's our variable. So the first thing I do to R, times it by 5 gives me my 5r. The next thing I do to R, take away 2 and it gives me an answer of 13. I'll come back the other way. I add 2 to 13, I get 15, good. Divide it by 5. So R is 3, 5 times 3 is 15, minus 2 gives me 13. Happy with that? Everyone get that? Good. What I'm going to show you next is very, very similar to that. But at schools they're very keen on these. They're called function machines. Anyone heard of a function machine before? No? We're also not teaching it at school.
I have.
Yeah? Okay, years ago. Right. All a function machine is what you've just done with the flowchart method, but instead of writing what's happening to the variable above the arrow line, above the straight line, you put what's happening to the variable in a box. And it's as easy as that. So if they give you an equation 3p plus 4 equals 16, when we were doing the flowchart, I wrote times 3 above the line. All we're doing here is we're writing it into a box. So the function is essentially being boxed. Okay? So I start off with p, I multiply it by 3, then I add 4, and it gives me 16. So I input p, and I output 16. Everyone happy with that? So it's exactly what you've just been doing, but instead of writing, you know, times by 3 and plus 4 above the line that you've been drawing, you just stick it in a box. So it's absolutely the same. So when you come back the other way, you do exactly the same as the inverse flowchart. You just switch what's happening. So instead of adding 4, you subtract 4. Instead of multiplying by 3, you divide by 3. And then you put your number in at this end. So this now becomes the input, and the output switches up that end. So 16 minus 4 is 12. 12 divided by 3 is 4. So it's absolutely the same as you've just done with the flowchart, but instead of writing the function above your line with your arrow on, you're just sticking the function in a box. Does that make sense? Yeah? So P equals 4. We put 4 into our equation. 3 times 4 is 12, plus 4 is 16. Okay? So have a go at that. 2a plus 4 equals 20. So what am I expecting to see in this box?
Times 2.
Good. Everyone see that? So I start on this end with a. First thing I do to it is multiply it by 2, because bid maths tells me to, and then I add 4. And at the other end, happy with that? Everyone get that? Then coming back the other way, I stick in 20. I take away 4, so it gives me 16. Divide by 2 gives me 8. I put 8 in there. 2 8s are 16, plus 4 is 20. See how they work? Not particularly difficult. That's probably the hardest one they can ask, but have a go. Let's do this one then. Starting point.
D divided by 3.
Good. So the first thing we're going to do to D is divide it by 3.
Minus 2.
And a minus 2, and the output is
4.
good. Start at the other end.
Plus 2. 6. Times by 3. 18.
So 18 divided by 3 is 6. Minus 2 is 4, and that's equal to 4. Okay. As with everything in GCSE Maths, there are ways of asking you questions on these subjects that can be quite difficult. I have no idea at what level they're going to ask a question, whether they're going to give you a nice noddy D, E, F grade one, whether they're going to give you a nasty C grade question. So the nastiest kind of question they can ask you in GCSE Maths on flowcharts or function machines look like this. So I'm going to give you, we're going to go through one together. I'll give you one to have a go yourselves, and there's another one in your assignment that I'll give you at the end of the lesson, okay? They come up once every 2 or 3 years. It's not every year, but if you get one, you'll need to have a good go at it, okay? So the way it works is exactly like the function machine. You have an input, you do something to the input, you do something else to the input, and then you have an output, okay? And they will give you something and it looks like that. And all they will say, they won't show you this bit in brown, they will say the output is 3 times the input. Okay? So what they're saying is whatever goes in here, the answer is going to be 3 times that. So from that information, you need to create the equation that you're going to solve. Okay? So, in this instance, I'm going to make up my input. I don't know what it is, so I'm going to call it A. Okay? Are you happy with that? The first thing I do to A is multiply it by 2. So it becomes 2A. The next thing I do to it is plus 3. So I end up with 2A plus 3. And this is equal to my output. And they will always give you a line that says the output is 3 times the input, or 2 times the input, or 4 times the input. So what does that mean? If I've input A, what's my output? Can everyone see that? So if my input is A, and my output is 3 times my input, exactly as James says, my output is 3A. Can everyone see that? And then what you do is you create your equation that you need to solve. So here, I've got 2A plus 3 on one side, because I have A, I multiply it by 2 and I add 3, so I end up with 2A plus 3 on that side, then that is equal to my output, which is 3A. Does that look familiar? Can you recognise what that is? Can we solve it? Yeah? It's a 3-step equation. It's got a variable on both sides. Yeah? So let's solve it then. What was our first step to solve a 3-step equation? Good. So I've got 2 A's over here, so you want to bring the A's together. So I've got 2 A's over there, I take away 2 A's on both sides. So it leaves me with 3 on this side, oh, and lo and behold, A on that side. So A is equal to 3. So when I stick 3 in here, 3 times 2 is 6, plus 3 is 9. The output is 3 times 3, which is 9. My answer is correct. So can you see how it works? You have to build the equation and then solve the equation to work out the number that satisfies this rule. Okay? So I'm going to give you another one to try now, and you'll have another one on your assignment. So this is your chance to have a go. You've got an input. I don't care what you call it, A, B, C, D, E, F, right? You're going to multiply it by 4, divide it by 12, and you're going to have an output. But that output is twice your input. Work out what the values are. Okay? So we need to reformulate the equation. So what letter did we go for? A. Let's start with A. So we started with A. First thing we do to A, so it gives us, brilliant. And then the next thing we do, good. So we have 4A and we take away 12, and that's equal to, good, twice the input. So the input's A, the output is 2A. So it gives us the thing that we need to solve. Okay? And we know it's a three-step equation because it's got the variable on both sides. So what do we do next? Good. So we take the 2A away from both sides. So if we do that, I know on the left-hand side it leaves me with 2A minus 12, and on the right-hand side they've cancelled each other out, so there's nothing there. So it's 0. Nothing in maths is 0. Okay? Look really familiar now? Okay? The fact that we have 0 over there, it's no big deal. It could be 2, it could be 10. It's just another number, 0. So I've got 2A minus 12 equals 0. First thing I do is plus 12 on both sides. So you have 2A equals 12. Divide both sides by 2. And then A equals 6. I'm going to finish off solving equations before we go on to inequalities by talking about these, because I didn't really know where to put them, and it's a one-off slide because it's really hard to explain where it fits in with what we've done so far. It definitely fits in with what we've done so far, and every 2-3 exams they'll throw something like this in, and what they're saying is A diamond B means A plus B, and then they'll say is what is the value if I have 3 diamond 6. So you swap the diamond for the symbol and it becomes 3 plus 6 equals 9. So they're just showing that in algebra you don't have to use plus, minus or A's and B's. You can use symbols as well. And I think that's why they do it, to show you that in maths you don't have to just use letters and numbers and pluses and minuses. You can use diamonds and squares. To show you a more complicated version of the same question, and there are some in your assignment, you've got C squared D means 2C plus D. And then now what they go on and say is, so if this means that, if I substitute 2 and 5 for C and D, what's the outcome of putting them in here? So all it's asking you to do is swap C for 2 and D for 5. So it becomes 2 times 2, which is 4, plus the 5, which again is 9. Can you see what they're doing there? Okay? And that's us done, really, the first learning outcome. We did the second one yesterday. Happy with that? Excellent. Last bit of the lesson, we're going to move on and we're going to talk about solving linear inequalities. Anybody remember what I said an inequality was yesterday? What does it read like? What does unequal mean? We know something good. We know if something is equal, we call it equal. If it's unequal, it's not equal. And that's quite literally what we're going to do next. We're going to look at things that aren't equal. Okay? So up to now, we've had a seesaw that we've balanced, and the reason we've done the same thing on both sides is because we had an equal sign there. Inequalities means we're going to get rid of this equal sign and we're going to put a different sign in there. Okay? And they're called inequalities. The symbols that go in there instead of an equal sign are called inequalities. So instead of having the equal sign, we just swap it for these. Okay? Greater than or equal to, less than, and less than or equal to. Everybody's seen these before. Are you happy how to read them, or do you get confused with them? The way to read them is the wide end is the big value. Okay? So if I put A and B here, A is greater than B, because it's at the big end. A is bigger than B. You can read them both ways. The trick with these is I can say B is less than A. So if I read it that way, A is greater than B, exactly the same meaning, if I come this way, is B is less than A. Okay? If I put A and B here, A is greater than or equal to B. So in this instance, A can be the same value as B. Here it couldn't be. It had to be bigger than it. It can be 0.001 bigger, but it can't be the same. Okay? We do the same here. A is less than B. A is less than or equal to B. For some reason, when people see inequalities in exam papers, they kind of lose the plot for some reason. They have no idea what people are talking about. So we're going to just show you that it's exactly the same thing. We'll read these, okay? X. What's X? What's it saying? X is.
Greater than 4.
Yeah, so you read it this way. X is greater than 4. So can it be 4? No. Can it be 5?
Yeah.
Yes. 6, 7, 8, 9. So when you're reading it, it has a meaning. It means that X can't be 4, but it can be 5, 6, 7, 8, 9, 10. In Unit 2, that's all they want. Nice round numbers. They don't want 4.001 for, they're not going to get that clever. Just nice round numbers in Unit 2. And that's where you'll see these, okay? This one here, what's it saying?
It's less than
14. Brilliant. So can A be 14? Can it be 15?
No.
Can it be 13? Good. So there's a meaning. An A doesn't have one value, it has a lot of values it can be, yeah? So before, when we were using the equal sign, A was equal to something, and that was it. The only thing you have to remember about inequalities is it doesn't get allocated one value. It can have a lot of values that satisfy what it's saying. So A is less than 14 means it can be 13, it can be 12, it can be 11, it can be 10. And in a minute I'm going to show you how you can represent that, like on a number line. Okay? So R is greater than or equal to 8. Read it from the variable that way. So can R be 8? It can this time because it's got the equal symbol. Yeah? Read this one then. What does that one say? Good. P is less than or equal to 3. Can it be 3? Can it be 4? Can it be 2? Yeah? See what I'm saying? So it can have a range of values. It can be 3, 2, 1, 0, and so on. Finally, this is about as complicated as you will get with respect to inequalities. And here, what we're saying is x is trapped between two values. Okay? So x has got a range of values, but it's got an upper limit and a lower limit. And you read it from the variable, from the x. Okay? So when you talk about what this means, you talk about it reading it in both ways. Okay? So when we read it this way, what is x? Is it? It's greater than minus 4. So can it be minus 3? Yeah, because minus 3 is greater than minus 4. Okay? But there's an upper boundary. What does this say when I read from x that way? X is less than or equal to 3. So can it be 3? Can it be 2? Yeah. So there's a range of values that x is trapped between. Okay? And we're going to have a look at that one quite closely in about 5 minutes. But what I want to do first is strike while the iron's hot. Anybody recognise that? What is it? Brilliant. So when you see these in exams, people don't even attempt to answer them. And I know they can answer two-step equations. It's a two-step equation, but instead of having an equal sign, they've swapped it for a greater than sign. But you can do two-step equations, I know you can. And it's the same. It's absolutely the same. So all you do, instead of writing equals down, you just put that symbol down, whatever symbol they give you. So let's do it as a two-step equation. Can you see that it's a two-step equation? Brittany, does it look familiar from earlier?
Yeah.
So let's do it then. So what would step 1 be?
3 times that. Or after.
Yeah, two-step equation, plus 2. So I'm left with 3x. I haven't got an equal, I just use that, is equal to 6. What's step 2?
Divide by 3
So x,
equals 2.
not equals,
And we want to.
just use the symbol. Can you see that nothing has changed? I've used exactly the same processes as when that was an equal sign, but instead of putting in equals, I just put that symbol in. So my answer now means something different. Instead of x having equaling 4 or 2 or whatever, x has got to be greater than 2 to satisfy this. So what can x be 2?
No.
Can x be 3? So let's put 3 in. 3 times 3 is 9, minus 2 is 7. 7 is greater than 4. It works, yeah? So when you get these questions with an equation, but it's not got the equal sign, it's got greater than or less than, or it's exactly the same. In your mind, picture the equal sign, but make sure you write down the greater than sign. I get a lot of students, once I've shown them this, start writing down the equal sign because I've told them it's exactly the same as an equal sign. Make sure you put the greater than or less than sign, okay? So have a go at those two. So a plus 6 is less than 14. 3p plus 5 is less than or equal to 26. So the first one then. A plus 6 is less than 14 is what it's saying in English to us. So what do I do to get a on its own?
Minus 6.
Good. Minus 6 on one side. I'll do the same on the other. So a has to be less than 8. Yeah? So let's try that. If a has got to be less than 8, can it be 8?
No.
Can it be 7? So I put 7 in here. 7 plus 6 is 13. I know 13 is less than 14. Let's always test your answer. Yeah? 3p plus 5 is less than or equal to 26. So we recognise it now as a two-step equation. Rather than having an equal sign, it's got a less than or equal to sign. So what's step 1? Minus 5 on both sides, leaving me with 3p is less than or equal to 21. Everyone happy with that? And then the next step, divide both sides by 3 and it becomes p is less than or equal to 7. Okay? So now, can p be 7? Yes, because it's got the equal to. So let's put 7 in. 3 7s are 21, plus 5 is 26, so 26 is equal to 26. We're happy with that, yeah? Sorted. That's it. Okay. So let's move on and show these inequalities visually, which is what they're going to do. Okay? It's one of their favourite questions, is showing inequalities on number lines. There we go. Okay. Let's go through some of the real basics then. Let's look at greater than and less than and greater than or equal to. Okay? You're going to be given a number line and they're going to ask you to represent an inequality. So let's just choose our favourite, A. And it's greater than 8. So we've got A is greater than 8. So the way to represent this is on the number line with a circle. Okay? Now, with the circle, if it can't be that number, you leave it empty. If it can be that number, in other words, if it was equal to it, you would colour it in. So in this instance, we leave our circle empty. To represent all the values that 8 can be, so it can be 9, 10, 11, but it can't be 8, you draw a line that represents those values. So you would draw a line that goes off to infinity in that direction. Thank you for correcting. Let's look at A is greater than or equal to 7. So it's exactly the same as we've done, but this time we draw a circle at 7. We colour it in because it can be that number, and then we draw our line off to infinity. Everyone happy with that? Yeah? Let's look at less than. So A is less than minus 5. So here you draw a line at minus 5 because you know A's got something to do with it, and less than minus 5 means it's represented in that direction. If A was less than or equal to minus 6, you would draw a circle at minus 6 and colour it in and draw something that way. Everyone happy with the basics of how you represent a variable with an inequality on a number line? Good. It's going to get a whole lot worse for you. Because their favourite type of question is where the variable has got an upper and lower boundary, but nothing changes. If you read it from the centre, from the letter, the variable x, you then plot whatever it is you're reading. So let's have a look at this. I'm reading it from x this way. So what's the number that I'm interested in that I'm going to circle? Can you see that? So I'm going to go to -4 and I'm going to put a circle there. Do I colour my circle in?
No.
No. Brilliant. Let's go this way. What's the number I'm interested in? 3. Can it be 3? So we colour it in. Brilliant. So x is greater than -4, so I know it's that way, and I know it's less than or equal to 3. So x has got something to do with -4, but we don't colour it in because it can't be -4, and x has got something to do with 3. You colour it in because it can be 3, and you join the two circles that you're drawn. Does that make sense? Okay, have a go at that one then. So n is an integer such that n is greater than or equal to -1 and n is less than 5. So, like I said, nice and straightforward. They're giving you the numbers. Good, Ali. So -1 we put a circle and we colour it in because it can be that value. 5 we put a circle, don't colour it in, and join the lines. So the number line that represents n is greater than or equal to -1, n is less than 5, is that. Happy? Good. One more and then we'll call it quits. So where am I going to put my circles? -3, am I going to colour it in? And am I going to colour it in? Happy? And that's inequalities on number lines. Good, good, good. Right, one more thing to do. They can give you the number line with the inequality represented, and you have to write down what the inequality is. So this is the opposite of what you've just done. So you've just drawn the number line from the inequality. The other way they can give you the question is give you the number line and you have to write down the inequality. Does that make sense? So just read what you've got. So our variable is r, and it's got something to do with 5. So what's r to do with 5? Where is r in respect to 5? Greater. Can everyone see that? So r is to the right of 5, so it's greater than 5. Can it be 5? No. So we don't put the... So the inequality that represents this number line is r is greater than 5. So just start off with whatever variable they give you, write down the number that they give you, and then work out if it's greater than or less than, and can it be equal or isn't it equal based on whether this is coloured in or not. Okay? So have a go at that one then. It's to do with x. So write down the inequalities, because it's bounded, it's got an upper limit and a lower limit. So x has got something to do with -1, x has got something to do with 4. And let's see if you can get the inequalities associated with this. I'll give you this one for nothing. It's nice and easy on the number line, because if it's to the right it's bigger, if it's to the left it's smaller, isn't it? But don't forget to read from x. Okay? So on the first one, x is something to do with -1. So x is greater, so I'm reading it from right to left, it's greater than or equal to, because it's coloured in. Yeah? And then reading from x again, x is something to do with 4.
That way.
Less than. X is less than 4. Get that? Is that the way you meant?
Yeah.
Yeah. Okay? So x is less. Happy with that? One more, and then we'll see where we are. So, my variable is p this time. Got a little p at this end. So I've got p, it's something to do with p, it's something to do with -2, and it's something to do with the number 2. So reading from p in both directions, what is p relative to -2? Good, it's greater than -2. Can it be equal to it?
No.
Oh. And p is something to 2.
Right, oh no.
P is less than 2. It's to the left of 2. So p is less than 2. Can it be equal to 2?
Yeah.
Yeah. Happy? here's to show you that they do use inequalities in exams, and I've got a couple of examples in there of the number line type questions and so on. Everybody recognise it? So step 1? Brilliant. So I've got 3t is less than 30. Divide by 3, divide by 3, t is less than. Fantastic. What they tend to do in the exam is, in this one they didn't, because that's the total and that was the end of the question. But they can go on and say, now write down an integer that satisfies that inequality. Lots of big words. All it's saying is, give them an example of a whole number that you can put in here. So, can t be 10?
No.
Can it be 11?
No.
So what can it be?
No.
So if you write 9 or 8 or 7, you'll get that other mark that they tend to throw in. And I think it's like that on your assignment. Yeah? And that is equations and inequalities, and they are linear inequalities done. So we've done all the objectives that we needed to do